Okay, so this problem says that fuel economy estimates for automobiles built 1 year predicted fuel economy estimates for automobiles built 1 year predicted a mean of 27.8 miles per gallon and a standard deviation of 5.2 miles per gallon when you're doing highway driving. You want to assume a normal model can be applied and use the 68, 95, 99.7 rule to complete parts A through E. So we need to first draw the model, and so we remember that for the 68, 99.7 rule, or for a normal model, it's defined by its mean and its standard deviation. You have the mean at the center, and then to get the 68% of the population is within 1 standard deviation of the mean. So this would be the mean plus 1 standard deviation is on one side, and then you could expand that, and then you could do the mean plus 2 standard deviations, and then we're going to go out the mean plus 3 standard deviations. So we'll do that one more time. I can just copy this and then paste it and then change that to a 3. And it looks like I want these all to be a little bit wider, so I can highlight all of these columns like this and kind of make them all the same length, like just by grabbing that, so they all kind of fit in there. And on this side, I want to go to the left of the mean, so I'm going to do the mean minus 1 standard deviation. So I'm going to grab, I'll grab this, and copy it, and I'll put it here, paste it. I have to put it here and paste it, or not, okay. I'm going to copy this, Control C, and then I'll paste it here, and I'll paste it here. But what I want to do here is I want to do the mean minus 1 standard deviation. And then on this one, it's just as easy to type, isn't it? Mean minus 2 standard deviations. And then the mean minus 3 standard deviations. So if you're being smart here, what we'll do is we'll build a little calculator to no matter what the mean and the standard deviation, the given mean and standard deviation are, it'll compute these numbers for us. So I'm going to go over here to the side. I'm going to write a normal model. And then I'll put mean and then standard deviation here. And I'm going to have that input in these cells right here in I5 and I6. So what I'll do is I'll change the ribbon and I'll just kind of make those yellow, and then I'll put borders. And so what that's going to do is allow me to just type in the mean and the standard deviation. So for example, on this problem, the mean was 27.8, and then the standard deviation was 5.2. So if I want to draw the model, I'm going to say, all right, take whatever the mean is, which I've input in I5, and place it right here. So I'm going to put the equal sign, and I'm going to grab the mean. And I want to go out 1 standard deviation. So I'm going to say equal sign, I'm going to take the mean, and then I'm going to say plus 1 standard deviation, which is in I6. So I take the mean, which was in I5, and then I add I6. And I hit enter. And then now I want to go out 2 standard deviation, because I want to do the mean plus 2 standard deviation. So I'm going to do equals the mean, and then plus 2 times the number of standard deviations, which is right there. And I hit enter. And then the mean plus 3 standard deviations. So I'm going to do an equal sign. I'll do the mean, and then plus 3 and the times, which is the shift on the 8, 3 standard deviations. So standard deviation is an I. You're doing it this way, then every time I get a new problem, I can just change right here, and I'll already know it'll automatically generate the values. And then here I'll just do mean minus 1 standard deviation. And then I'll just continue that here. So equals, and you click on I5 minus 2 times I6, and then finally equals I5 minus 3 times I6. Okay, so this is the model, and I can take my pen and I can sort of draw. Let's see if it'll. I'll draw kind of a silly looking model, or I'll try my best to make it look good. That's not so bad. And what we tell you, it should be centered at the mean, and then if you go out 1 standard deviation, this is 68% of the data is within 1 standard deviation, so between 22.6 and 33. And then 95% of the data, all the cars, 95% of all the cars that have been, for 1 year, in production for 1 year, 95% of them have a miles per gallon between 17.4 and 38.2. And then 99.7, so almost all the data has miles per gallon between 12.2 and 43.4. So now that I have the model drawn, it should be pretty easy to pick which of these is, it's going to be B here. Okay, now it says, in what interval would you expect the central 68% of the autos? Remember, the middle 68% is within 1 standard deviation, so that's going to be 22.6. That's this number right here, 22.6 to 33. Because I just went out 1 standard deviation on either side of the mean. Now it says, about what percent of the autos should get more than 33% of the miles per gallon. So let's see if we can understand what that means. So I'm going to erase this drawing and then draw it back in. So I'm going out like this. Imagine that's a normal model. And more than 33. Okay, more than 33 is this stuff that is beyond 1 standard deviation. So this is 68% of the data right here within 1 standard deviation. So how much do you have left? Well, you have some on this side and you have some on this side. The whole thing is 100%. So 100% minus 68% is equal to 32%. But you have to split that between the two tails. So you do 32% divided by 2 to get 16%. And of course you could do those calculations on your computer on the Excel if you wanted, but there would be 16% on the right hand side to the right of 33, and 16% of the data would be to the left of 22.6. So we'll say 16%. And now it says, using the 68, 95, 99.7 rule, about what percent of autos should get between 33 and 38.2. Okay, so let's look at our model again, and I'm going to erase again because I got to do some new thinking. So I always start by drawing the picture. Here's my mean. Keep hoping my normal model gets better. Oh, it's getting worse. All right, so between 33 and 38.2. So we want to know this area right in here, between 33 and 38.2. Well, what do we know already? Well, we know that 68% of the data is within 1 standard deviation. So we know this is 68%. Now we also just computed that this number right here is 16%. That amount right there, that whole thing is 16%. Okay? Now, if that whole thing is 16% and we just want this part of it, the part between 33 and 38.2, it would be great if we could figure out how much is in here. Because if we subtracted this part from the 16%, we would get what we're looking for, the percent that we're looking for. So how would we figure that out? Well, 38.2 is 2 standard deviations to the right. And we know that, let me get some of these colors off here. We know that 68% is within 1 standard deviation, and we know that 95% is within 2 standard deviations. We know this is 95% of the data within 2 standard deviations. So same logic as the previous problem. That means you have 100 minus 95, or 5%, to split between the tails beyond 2 standard deviations. So 5% divided by 2 is 2.5. So 2.5% of the vehicles have a miles per gallon beyond the 38.2. Then you know that 16% of the vehicles are beyond the 16%, I'm trying to make this a percent, but I don't want to take it, are beyond 1 standard deviation. So if we do 16% minus the 2.5%, we're going to get the area that we want, which is the amount between 33 and 38.2. So you might want to do that in your, you could, let me get back to just regular typing. So if you do equal sign 16%, or just 16 minus 2.5, just remember that it's going to be a percent, you'll get 13.5, which is the percent of the autos between 33 and 38.2. Okay, now describe the gas mileage of the best 2.5%. We just talked about this, right? The 2.5 to the best 2.5 is going to be more than 38.2 miles per gallon, because anything beyond 2 standard deviations. So that's going to be choice B there.